Hi, welcome to the Calculus 1 lecture series. And we are still at unit number 2. We talk about the derivatives. And this is the second part of the lecture number 12, the implicit differentiations. So on the first video, we talk about the general formula and method, how to take the implicit differentiation. Then for the second video, we're going to specifically take a look how do we take the derivative of the inverse trig function by using the implicit differentiation concept to derive the formulas here. All right, so okay, let's go ahead and go back to our worksheets here. Okay, so this is the second part of video number 2. Like you can see, we did all this definition about the implicit differentiations here. So in here we say, okay, now let's take a look. What is the derivative of the inverse trig functions here? So what I want to do here is first, I'm going to write down the 6 trig functions formula, the derivative of this 6 function. Then I'm going to prove one of them. The reason why I want to prove one of them, because it's very important, and it's because we're going to use the proof to try to find the derivative of the inverse function in any other kind of functions here. All right. Okay, so the derivative of the inverse trigs here. So let's write down the 6th formula. And also, you know, if you know how to prove it, you don't really have to remember it because it's kind of difficult to remember, right? Okay, so this is d the dx here. So first one's here is how about is arc sine x. Okay, so the arc sine x, the formulas will be 1 over 1 minus x squared. Okay, now let's do the typical one. After sine, what do we have? Arc sine what? Cosine x. Arc cosine x is here. Arc cosine x, this will be -1, and this is 1 minus x squared. Then the next one we're going to talk about, we have 6 trig functions, right? Is arctangent. So the arctangent is 1 plus x squared for the 1. Then the next one's here, we want to talk about the arccotangent. So this one's here will be the -1, 1 plus x squared. Now the next one's here is the arcsecant. This will be 1 over x, and this is x squared minus 1. And then here, this is d dx, this is arc cosecant, right? And this one's here, it will be -1 x and x squared minus 1. In fact, if you see the patterns here, so all this has what? Has negative signs, right? So if you remember 3, you will remember the other 3s here. They are the same thing except the negative sign. And then let's take a look. How do I prove it and why it is important here? Okay, so now let's take a look at the inverse functions here, right? So now let's start here. So I know the sine and the arcsine, they are inverse. So if you put a function and it's inverse, what are going to be? It's going to be what? Going to be by itself, right? Will be equal to x, just like we said, you know, just like we did before. If you put an e and the natural log, it will become, you know, if you put an x, this will be x's, right? Or if you have natural log e to the x, and then this is x, right? So we know the natural log and the e, they are the inverse function. So if you put the inverse function together, it will just be x. So that is, this is what we have here. Okay, so now in here, I'm going to take the derivatives here, all right? So now I'm going to take the derivative on both sides here. Okay, so if you take the derivative on both sides here, so this is the chain rules, right? So the first layer, this is the chain rule. So this is the first layer of the chain rule. We always use the same color. And this is the second layer of the chain rules, right? Okay, so now if I take the derivatives here, so the first layer sine going to become what? Going to become cosine, right? So the layer still here. So it's inverse x, correct? Then by the chain rule, I need to take the derivative of the inside the second layer. So this is x sine x. I need to take the derivatives. Cool? Okay. Now this is equal to 1. So here. Okay. And now in here, let's take a look here. So what is the x sine x? So when we did the inverse function, so x sine x, really, if you put an arc, sine, or trig function, it will give you what? Will give you angles, right? It will give you angle. So that means sine theta equal to what? Equal to x. So now if you do a triangle here, so if you say this is your angle theta, sine is opposite over hypotenuse. So this will be x over 1 because the x is equal to the x over 1, right? So it's x over 1. Then by the Pythagorean theory, right? So by the Pythagorean theory, what is here? This is 1 minus x squared. Cool. And so now, by the, remember we said y prime since, right? Implicity. So I know the sine x sine x, the derivative is equal to 1 over cosine x sine x here. Am I right? And x sine x here, just like we say x sine x is theta. So this thing is what? This thing is theta. So this one here is the 1 over what? 1 over cosine theta, right? So this is 1 over cosine theta. So what is cosine? Cosine is adjacent what? So it's 1 over cosine. So the cosine is adjacent over hypotenuse. So it is what? Is 1 over, so this is the, okay, so this is the 1, and this is adjacent. So this is 1 minus x squared over hypotenuse is 1. So right, now you simplify these fractions, you flip it. So this is 1 over 1 minus x squared. So that is why. So this the sine inverse prime, right? The prime here, you can rewrite this is just the derivative. So it's a derivative of the sine x sine x, right? So that is how do we prove the x sine, the formula. That's how do we prove these formulas here, right? So the x sine is equal to 1 over 1 minus x. It's very, very simple. You just use the inverse functions property, then you kind of like doing the same thing like we did the chain rule. You take the derivative on both sides and solve it for that. All right. Okay, so now let's take a look at some examples here. So this is f of x is sine x sine, right? Okay, so in here, obviously, if you look at our basic formula, so this is what? This is the basic formula. This is 1 over square root of the 1 minus x squares, right? So okay, so what is your first layer? Your first layer is sine x sine, right? Then what is your second layer? Is x cubed. Okay, so now let's see, we still remember how, so you can do a little table if that you feel is helpful. So this is x sine x cubed, and this is x cubed, right? So remember, that's how do we do chain rule, right? So this is x is the first layer, and this is the second layer. Okay, so the first layer, x sine is 1 over okay, 1 minus, right? So what is here is your second layer. So it's x cubed to the square. So this one will give you 1 over 1 minus x cubed 6. Then the second layer is what? Is 3x squared. Cool. Then after you do that, what you need to do, you do the multiplications, right? Okay, so now we can write it. So what is my y prime over the f prime? Half. It will just be the 3x squared and the 1 minus x6. Okay, so now let's take a look at the second one. See here, this is the arctangent to the third power. You see here, so what is your first layer? Your first layer is 3, right? Okay, so your second layer, what is your second layer? Is the arctangent. Am I right? Okay, so now let's try. Okay, so if you want to use a little table to help you, you can do that. So your first layer, so this is the arctangent x to the cube. Then your second layer is arctangent x here, right? Okay, so the first layer, remember, is a cube, right? So it's power rules, right? So you will say this is 3 arctangent x to the 2. Now arctangent, this is your second power, second layer of the onion. So what you do here, so the arctangent is what? 1 over 1 plus what? X squared, right? Then you multiply them together. So what is y prime or the f prime here? So it will be, you multiply, so this is 3 arctangent x to the second power over 1 plus x squared. Cool? Okay, now if we still have issues here, let's try to take a look at the other ones here. All right, so these ones here, whoa, the first thing you will see, I have x, now I have times a function of x here, right? So what rule you need to know? We did this, what is here? We need to use the product rules, right? Okay, so let's try to the product rule. Okay, so the y prime here is f, first one, x take the derivative is 1. So it's 1 times arc cosine x, then you plus the x, then you take the derivative of arc cosine. What is arc cosine? Is -1. And what is here? So there's 1 minus x squared, that's right? All right, so now that is what is our answer. So our answer, if you combine it, this will be 1 minus x squared negative x plus arc cosine x. All right. Okay, now part D here. Part D, let's see. You know, for here, we said, oh, I have a lot of layers here. What is my first layer? My first layer is E, right? That's exponential. Then what is your second layer? Second layer is a cosecant. Okay. Then what is your third layer? Your third layer is x squared here. Okay, now let's see, we be able to get this or not. Okay, let me see if I can give a little bit more space here. Okay, so let me see here. All right, so come on. All right, so it doesn't look like I want to give me more space. Let me see here. Oh yeah, okay, good. All right. Okay, so now we have several layers. So for those type of the problems, I definitely will recommend you, let's try to do a table. All right, so put the first layer. First layer is E. So this is a cosecant, arc cosecant x squared. So make sure you highlight it. This is the first layer. Then after you do the first layer, the next layer is a cosecant, arc cosecant x squared. So this will be your second layer is cosecant. Then your third layer is what? X squared, right? Okay, so this is your third layer. Okay, now let's take the derivative. Okay, so E, we know the E we just did by itself. So it's a cosecant negative arccosecant x squared. Okay, now the cosecant, we just give you the formula, cosecant. So what is the cosecant? This is -1. Then it's x, right? So but what is the layers here? So it's x squared times 1x squared minus 1. So it's x to the fourth minus 1. Right? Now in here, the last layer is 2x. Then you multiply all of them together. So I will have y prime is equal to the f prime x. Okay, let's see. This one we put it in the denominator. So this is x squared, and this is x fourth minus 1 times negative 2x, and e, the cosecant arccosecant x squared. And if you want, we can simplify a little bit. Not much, but still we can. Okay, I think this is x, and x I can cancel out 1x here. And so if you simplify it, the answer will be, so this is the x, and then this is the x fourth minus 1, negative 2e, and this is arccosecant x squared. All right, that will be the answers here. All right, so now let's take a look at our next problems here. So let's say find y prime for this one. What can you conclude about arcsine x plus arcsine? All right, so we say find the y prime. Okay, so let's take the derivative. So I know y is equal to here. I can just say the y prime is equal to the derivative of the arcsine. What is arcsine? We just the formula we have. What is the arcsine here is the 1 over 1 minus x squared, correct? Then what is the arccosine? So it's a negative 1 over 1 minus x squared. I have what? I have equal to zeros here, right? So what do I mean I have to equal to 0? That means y has to equal to some constant. Right, so y has to be equal to some constants. So I know the y equal to a c depends on the different value of x. You might have a different constants here. All right, so for examples here, so for example, okay, so if I say, oh, well, let's see here, if x equal to 0, so then the y, it will be arcsine 0 plus arccosine 0. What is arcsine 0 is 0. What is the arccosine 0 is pi over 2, right? So this will be what? This will be pi over 2 here. So that means the y is equal to pi over 2 here. All right. And so, you know, that's what we say. This one will be a constant. So that's very interesting to see that. Okay, let's take a look at number 5 here. I want to find the equation of the tangent line. So as you can see, we have so many of those type of problems, right? Equation of the tangent line. So if in order to find it, what is the first things we need to find? We need to find the slope. So how to find the slope? Take the derivatives, right? Oh, so this is arc sine x over 2. So this is 2 layers. So first layer is arc sine. The second layer is x over 2. Okay, so now let's see how do we do this one here. All right, so if you want, you can use a little table. Like we always say, you can use this table to help you. So this is x over 2, and the second layer is x2. So arc sine, all right, so the arc sine, the derivative is 1 over, right? So it's 1 over 1 minus x squared. So it's 1 minus x over 2, the square. Then this one's here, the derivative is 1/2. Then multiply it, right? So I know the f prime x is equal to 1 over 1 minus x squared over 4 times 1/2. Correct? Now I can plug in the x equal to square root of 2. So I say f prime to the square root of the 2. You plug the x equal to the square root of the 2, and you simplify it. It will give you what is here, square root of the 2 over 2 here, right? So you will get the f prime square root of the 2 is equal to the square root of the 2 over 2. And so also you can plug in the square root of the 2 into the f of x. That means this will give you arc sine x over 2. So it's the square root of the 2 over 2. Right, so what is the square root of the 2 over 2 arc sine? So this is a pi over 4, right? So this is your y value. So equation, so you're going to have a y value is the square root of the 2 and the pi over 4, and the slope, right? This is the derivative is always, this is the slope. So what is my tangent lines here? So what is my tangent lines here? So my tangent lines here are going to be what? My tangent lines here are going to be y minus pi 4 is equal to square root of 2 over 2 x minus square root of 2, right? So that will be my tangent lines here, okay? So I'm going to use this implicit differentiation to show one very, very important formulas here. And hope let me see here, I can get to the next page is here. Okay, so let me see, I get to the next page is here. Okay, so let's see here. All right. So I've got the next page is here, right? All right, so I'm going to show you how do I find so this is a very important formula. Okay, how do I find the derivative of the inverse functions? So it's f of the inverse primes here, right? Or you can say this is d to the dx f of inverse x here. Okay, so we use the same concept. That's the reason why I proved how do I get the inverse trig function. So because you can apply it in general function. So I'm using the inverse function concept. I know f and f inverse of the x here. This will be equal to x, right? Because f and f inverse kind of cancel, just like a natural log e to the natural log. They are the inverse function for each other. Then I will take the derivatives both sides. Okay, so when you take the derivative of both sides here, so then you need to choose. So first one's here, the first rule, first layer, if f primes, right? So you say f prime, f of the inverse x. Then the chain rule is the second layer. So it's f of inverse x. The prime is equal to 1. Okay, so let's try to do this again. So this is my first layers, right? So then this is my second layers, right? So when you take the derivative on both sides, then the chain rules here. So in here, this is the chain rules, right? Okay, so now you want to find the derivative of the inverse. So f prime x really is f prime x the derivative will just be equal to what is 1 over f prime. So this is the first derivative of f of x and f inverse x here. Okay, so in fact, this is a very important formula. It will very, very helpful to find the inverse function. If you remember, right, so how do we find the inverse function if y equal to the f of x, right? So if y, so we learned that before. So we say y is equal to, for example, x squared plus 3x minus 5. So how do you find the inverse, right? From the pre-cal, you say, hey, I can change that. First, I switch the variable. I will say this is x equal to the y squared minus 3y minus 5. Then we're solving for y's, right? Then that is your inverse, right? That's what is the method. Just like in here, because this is implicit, because we have very difficult to solve for y's here. So for this one, maybe it's not like too bad. But if your function is very complicated, you cannot really solve the y, as a function of x. So that is why use the implicit equation definition, we'll be able to find the derivative of the inverse function. We don't really need to solve in that. All right, so we just need to use the inverse and the function itself will be equal to x, and then you use the chain rule, you take the derivative. All right, so that is why you might ask why we talk about this in this section. It is because, when I try to solve the inverse, you can solve the inverse and then take the derivative, right? But sometimes it's very, very difficult to algebraically try to solve the y become x and try to find the inverse function. Then you can use the chain rule to solve this problems here. You still can get your derivative of your inverse function without physically solving it by using the implicit concept. All right, that's it. And so that is for this lecture and implicit differentiation, like I mentioned. This is a very, very important skill for the derivatives here. Okay, I hope you get a good understanding of this. And nice talk to you, and looking forward to talk to you to our next topics here. Okay, bye.